Dear students, in an earlier class, we have discussed how to compare two population means. That is, means of a variable collected from two populations. We have used a procedure known as pooled t-test procedure. The example we have discussed was the mileage of cars with and without a new adding. But we cannot compare means of more than two populations. Suppose that the data on this variable is collected from three or more populations. Then pooled t-test cannot be used. So, in order to compare means of a variable collected from several populations, we use a procedure known as analysis of variance. We write it as ANOVA, analysis of variance. ANOVA is a method used for comparing several population means. Used for comparing several population means. That is, means of a single variable collected from several populations. And ANOVA is a very vast area where we can think about many procedures like one-way ANOVA, two-way ANOVA, more than two-way, ANCOVA models, then MANOVA, so many procedures are available. We consider the simplest kind of ANOVA, namely one-way ANOVA. We first explain one-way ANOVA. We will expand this to two-way ANOVA, etc. later. Now, in the form of a definition, one-way ANOVA is called so because it compares the means of a variable for several populations that result from a classification by one other variable called the factor. One-way ANOVA is so called because it compares the means of a variable for several populations that results from classification by another variable known as factor. That is, we classify the population by population of a variable by another variable known as factor. And the possible values of the factor are referred to as levels of the factor. Possible values of the factor are known as levels of the factor. As an example, suppose that we want to compare the mean energy consumption of US households, and we divide the variable energy consumption into 4 populations, that is households in the Northeast, Midwest, South and West. The population under consideration is energy consumption. This energy consumption, the variable under consideration is energy consumption, and the population is the households in the US. And these households, that is the population, is classified using another factor, namely region, into Northeast, Midwest, South and West. And 4 populations, result of classifying the households by the factor region. That is, the population is US households. This population is classified into 4 by using the factor region, which has 4 levels. For the factor is region, the levels are Northeast, Midwest, South and West. The variable under consideration is energy consumption. The variable under consideration is energy consumption. Population is the entire US households. This population is divided into 4 categories using the factor region, and the region has 4 levels given. And one-way ANOVA can be generalized into or two-way ANOVA, three-way ANOVA, ANCOVA and many other ANOVA procedures. And remember this, one-way ANOVA is actually a generalization of pooled t-test procedure. One-way ANOVA is a generalization of pooled t-test procedure. For example, the variable is energy consumption. Suppose we consider only Northeast and Midwest. We can use the pooled t, assuming that standard deviations are equal. But when we have more than 2, that is 3 or 4 or more than that, pooled t-test will not work. In such cases, we use the ANOVA procedure. Here the variable is energy consumption. The population is US households divided into 4 using the factor region. Region has 4 levels. Now let me say what are the assumptions of one-way ANOVA. It is based on 4 assumptions: simple random sample, independent samples, normal populations, equal standard deviations. Simple random samples, independent samples, normal populations, equal standard deviation. And one-way ANOVA has the same robustness property as the pooled t procedure. It is robust to mild violations of normality assumption. It is also robust to moderate violations of equal standard deviation, provided that the sample sizes are equal. Sample sizes of the population from all the regions are equal. So it is robust to mild violations of normality, also reasonably modest to modest violations of equal standard deviation. Now the normality assumption can be tested by using what is known as normal probability plot. So a technique which we have studied. Equal standard deviation assumption is difficult to test. So a rule of thumb procedure suggested in the literature is, this assumption is satisfied if the ratio of largest standard deviation to smallest is less than 2. Largest standard deviation to smallest standard deviation is less than 2. We call this rule of thumb the rule of 2. Rule of 2. So we have 4 classification, 4 levels, and we have data corresponding to 4 levels. Then calculate the standard deviations, calculate this ratio. If it is less than 2, then we can reasonably assume that standard deviations are same. In addition, we can test normality assumption by using what is known as a residual analysis. Residual analysis is used in the regression context also, that we will see later. And in the context of ANOVA, a residual is an observation. So residual of an observation is the difference between that observation and the mean value of the sample belonging to that class. Suppose that mean value is x bar 1 for the first, consider the first observation. The difference is the residual. So residual analysis by considering all the residuals, and if normality and standard deviation assumptions are met, then the normal probability plot of all residuals will be linear. If normality and standard deviation assumptions are satisfied, you do the normal probability plot of the residuals, then it will be linear. So here residual means the difference between an individual observation and the mean value of that group. It is different from the residual in regression analysis that we will see later. So this is one way, the theory behind one way ANOVA. The population under consideration is divided into different groups by using another variable factor, and the levels of the factor are used to divide the population into different groups. And we have the variable in each group, and we compare the mean values using one way ANOVA. It is one way. We will see why it is one way. We will also see why it is analysis of variance in the next class.